Hi, this is John Guest, and this is just going to be a short video to go with the online materials for the questions in the September 2017 edition of the Economic Review. And one of the articles in that edition was on the economics of organised crime, or what can economics tell us about organised crime. And question 3 that went with that article was what factors will influence the size of the deadweight welfare loss in the market for stolen goods. So if we go on, all I've tried to do here in a PowerPoint slide is recreate figure 1 in that article. So we've got our downward sloping social marginal benefit line, we've got our upward sloping social marginal cost line, and of course the interesting thing with this diagram, and it makes it a little bit different from ones you tend to see in the textbooks, is that at no point are the marginal benefits greater than the marginal costs. The social marginal costs are always greater when we're looking at the number of thefts. So therefore, if the social marginal costs are always greater than the social marginal benefits, from society's point of view, it would be better if we had no thefts at all. But if the market was perfectly competitive, how many crimes would we have? Well, if it was perfectly competitive, this would be determined simply by demand, this line here, and supply, this line here. We'd be at point A, and TC would be the number of thefts if the criminal markets were competitive. And what the article did, which is really interesting, was to note that if organised crime acts as a monopoly, the monopolist would restrict output below this level, and this would reduce the level of deadweight welfare loss. Because remember, in this diagram, the level of deadweight welfare loss, if we have a competitive market, is area A, B, C, D. If the market was a pure monopoly rather than competitive, which is what we think organised crime might be, then organised crime would restrict the number of thefts below this level. And this is shown in figure 2 in the article. And by restricting output below the competitive level, in this example, a monopolist would actually reduce deadweight welfare loss, whereas in most applications you'll see in textbooks, we think about monopoly creating deadweight welfare loss. Well, something else that we think will also influence the size of deadweight welfare loss is elasticity. And all I'm going to do here is just alter the elasticity, the price elasticity of demand for thefts, and I'm going to do that in the diagram by rotating this line here around A. So we've now got D equals SMB1, and this represents demand that's become more price elastic, so people are more sensitive to stolen goods that they buy. By rotating this around A, if the market was competitive, the equilibrium would still be at the same point. Demand equals supply at point A, and the number of thefts would still be TC. Of course, what's happened here is that by changing the elasticity in the market, this changes the level of deadweight welfare loss. So if we look on the y-axis, instead of the intercept being at D, the intercept is now at point E. And therefore, the deadweight welfare loss of a perfectly competitive criminal market is now A, B, C, E. Remember, when demand was more inelastic, it was A, B, C, D. So the impact of making demand more elastic is that it increases the deadweight welfare loss caused by a perfectly competitive criminal market. So therefore, we can see with this simple example that elasticity has a big impact on the size of deadweight welfare loss. And you can think about this in the more traditional examples when you look at a textbook and you're looking at examples of perhaps the deadweight welfare loss of monopoly or the deadweight welfare loss of externalities. You could think for yourself, well, how would changes in the elasticity of demand and supply influence the size of that deadweight welfare loss? I hope you found this little video useful, and thanks for listening.